All right, Year 9. Let's have another look at question 8 from exercise 602 because it's a bit tricky as it involves proving stuff. Now with question 8, what you need to know before you get into it is a couple of facts about this little feature of parallel lines cut by a transversal. And that is when that happens, when the lines are parallel, we get pairs of angles created, and those pairs of angles given special terms. The first pair are alternate angles. So alternate angles in a pair, we'll just pick one. So alternate inside the parallel line and on the other side of the transversal. So those two are alternate. And they are equal. Very important because this comes up a lot in many things, Year 9 right through to Year 12. The other side of the transversal, start there and go the opposite side there. There's our other pair. Those two are alternate and also equal. You can tell too because this one is acute angle, so is that one. There's obtuse, and so is that one. And we can also then go from that and see that these angles here are opposite, vertically opposite, vertically opposite, opposite, opposite. So we've got all our angles labelled here, and we can go on to the next one, corresponding. And they've got to be on the same side of the transversal and above or below the parallel. So the right side above, they are corresponding. The right side of the transversal below, they're also alternate. Corresponding. Here on this side, the left side, underneath, left side underneath, corresponding, left side above, and left side above, they're corresponding. Corresponding angles are equal. And the last type is a bit inside the parallel lines. These two, the pair X and dot, they are not equal, but they do add up to 180. And they're called co-interior. And they are supplementary. Which means they add up to 180. This one, isosceles triangle. Particular type of triangle where you've got two sides the same length and the third one not. This one, you always have angle in between the two lines of the same length. Is one dimension, which these creates, these two angles are the same as each other on an isosceles triangle. Very important. So isosceles triangle, the angle in between the two lines are the same length. Then these two that are down the bottom here, they're both equal. So what does that mean for question 8? Let's have a look. We'll just take away all the stuff we've had so far and see if we can find parallel lines, alternate, corresponding, or isosceles triangles. So we've got our parallel lines marked. So there's our parallel lines. So it's something to do with parallel lines. Now we've got find PQR, which is this angle here, and we've got a 72. And by the looks of it, they're alternate. So PQR, in fact, that's what this is. This is straight from the answers. Angle PQR equals 72, and that's what that means. Alternate angles, RW is parallel to PV. RW parallel to PV is 72 because it's alternate. To QRW. So the language of proving means you've got to say, well, what is this element you're talking about, and why is it that measurement? Well, it's 72 because it's alternate to that one, and they're parallel lines. Okay, next one. In fact, I'll only do one more. This one is 4 bits of working before we get to our final answer. Again, we've got to find out what PQR equals. PQR, this is angle here. What's that one? So we've got to work towards it by using what we know. And the first thing, according to the textbook, TQU, I'll just do a little circle there. TQU is equal to 2TUQ. That one there, they're equal. Why? Because they're angles in an isosceles triangle. So we've got a line length's the same. That's 74. A triangle's 180. So 180 minus 74 is 106. So 106 gets shared between these two, which makes them 53 each. 53. So that's that one. QUP also equals 53. Where's QUP? Is there. Why is that equal to 53? Oh, we've got alternate angles again. Okay, parallel. They're parallel, these lines. And so alternate angles, parallel lines. That one there's 53. Now why do we need to know that? Because we've got to get to here and we've got to piece together another, so that's a bit there. We've got to piece together another bit of info. That's another isosceles triangle. This time 53's angle in the middle. So I'll put X there. What's that one and that one? 53, what's 180 minus 53? Equals 127. So 127 gets shared between these two, which is 63.5 each. There we are. And finally, we've got PQR, the angle after, also equals 63.5. And why? Because we've got parallel lines and they're alternate. So PQR is 63.5, alternate to that one. Here we are. Thank you.